Hi, I hope you are doing good. I am Abdullah. I am a full stack developer specialized in web and I am very passionate to build the software products. So in this video, I am going to introduce a DualStream live video application. So first I will show a demo and after that I will explain the architecture and how it is implemented and how the workflow. So this is the application. First of all, we have two kind of users. One is the host and one is the client. So the host will join a room with a join ID. So I'm connecting to the room. So the host is waiting for the clients. So once a client is joining with that same room ID, and I'm giving the name for my client, and then starting the stream. So first it will ask the permission for the webcam and for the screen sharing also. So the user now, this client now successfully streaming. So we can see in the dashboard, the host dashboard, that uses webcam as well as the screen sharing, and we can have the options to disconnect, and we can see the connected clients. So I will connect with my mobile phone. So I'm using my local IP. So you can see the exactly the changing. So I am connecting. I'm giving the permission. So yeah, you can see here the second as the Joe. This is my mobile phone. I added a fallback. We cannot share the screen, so that is with the fallback to the rear camera. So this is the application, and coming to the workflow and the architecture. uh, in this application, the two clients are communicating in the real time. So we have the HTTP protocol, but it has a limitation, like it is too terrible latency, because every time the client want to make a request, so that is why I used the WebRTC with the signaling server. So the flow of the WebRTC is like there would be a uh, two clients. One client will make a peer connection, and other client will make also peer connection, and there would be signaling server. So uh, we will make a peer connection with the passing the STAN configuration, and it will give a ICE candidate. The once ICE candidate will send through the signaling server to other, and the other to this one, and they will make a connection. After that, one client will uh, extract the media stream and will make an offer. That offer will send through the signaling server, and it will set in local description, and it will set in uh, remote description, and the other client will send an answer that will set in local description, and also in this the answer will set in local description. So after connecting, the WebRTC can communicate the stream without any help of the server. So we have multiple architecture to implement the WebRTC. Uh, I used the top mesh architecture. It is a simple one. The idea is, once a client is joined, client is joined, uh, everyone will create a new connection for them. So it is too terrible to scale. It is too terrible latency to scale, because every time a client is joined, need a new connection. But in simple way, uh, it is the best. And the next way is the MCU. It has a centralized server, and what it will do is it will take the streams from the client and it will encrypt, and after that it will send to the connected clients. And the next thing is the SFU. It is a more advanced one. It also centralized server, but it is not encrypting. It is not touching the stream. It is directly uh, taking the stream and passing through the connected clients. So the MCU have the negative, like it has a centralized huge server, but SFU is more latency and all. So this is architecture. and thank you.